I'm going to start. Hurry up, hurry up, hurry up. Because we have a lot to do. Hi. This is so weird because I've done this a few times and I'm still nervous on this very first opportunity to meet you. This is CS225. We'll talk a little bit more about the class in just a minute, but I feel a little bit like we're starting a semester-long party together. And every good party starts off with introductions. So that's where we're going to start here. My name is Cinda. I'm an alum of the CS department. My graduate degree is from the CS department here. So, you know, I have orange and blue in my veins, sort of, in a strange way. And I've been teaching this class for a while. I have a co-teacher this semester I'm very excited to be working with. His name is Wade. I think, Wade, they should call us Cinda and Wade, right? Cinda Wade? Yes. Okay, so I'm going to let him introduce himself.
Hi.
You'll get to know him more as the semester goes on. The way we're going to divvy up tasks is mostly I'm going to be doing lecturing. He'll be doing some of it. He's going to mostly be doing assessments and exams, but I'll be helping him. So we're really a team. Either one of us can be asked questions that you have. We probably prefer Piazza for interaction, but so that's us. You'll see how we divvy it up later. Much more important to you than either of Wade or I are our course staff. Now, there are approximately 50 course staff, and I said if 25 course staff show up to the lecture, I would buy them chocolate. And clearly, my incentive wasn't good enough. What would have been a better incentive to get people here? Pay raise. Oh yeah, don't even start. What's with the money? It's all about the money. Okay. All right. Nonetheless, I'm going to have them introduce themselves to you. There won't be a quiz about those introductions, but what I want you to listen for is the variety of degrees that they come from. I don't know if there's as much variety this hour as there was last hour. And the variety in years in school that they are. Just you know, try to use this opportunity to get to know a little bit about them. You'll know them better later, and they will know you. So here we go.
Hey everyone, I'm a new CA this semester, and I'm a junior in computer science. I'm really excited to be teaching assistant this semester. Well, actually, course staff, sorry.
Tell them your name.
Oh, my name is Ray Qian. You can call me Ryan if you cannot remember my name, because it's a super weird Chinese name.
We can have lessons later, and you can teach me how to say it correctly, okay? Okay.
Hi, everyone. My name is Ning, and you can also call me Timo. I study computer science, and it's my junior year, and it's also my third semester teaching this course.
Cool.
Yeah.
Okay, you can go ahead with that.
No,
All
go.
right, okay. All right. Good afternoon, everyone. My name is Rohan, and this is my 7th semester on the course staff.
Seven. He said 7.
Next semester will probably be an 8th one if I get hired again. But yeah, so yeah, that's it. I guess that's the best.
What's your major?
Oh, my major is CS, and my interests lie in cryptocurrency and smart contracts. So that's where my interest is, and that's where I'm doing my research and distributed systems as well. So yeah.
I'm Sylvia. I'm a junior in computer science and statistics, and this is my 3rd semester on course staff.
Hey, I also got a super weird Chinese name. My name is Jiaxing, and you can call me Kana. And I'm a new graduate TA here, and this is my first year master in CS. And hope you enjoy the class.
Where'd you go to undergrad?
Here. Oh. It's a 5-year program.
Got it. Cool. 5-year program. It's fun.
Hi, everyone. My name is Ian. I'm a sophomore in ECE. This class is a lot of fun and can be really enjoyable, and can also be a little bit scary, too. But
Tell them that yet.
It doesn't have to be. Come to office hours, be my friend, and I will do my best to make it not scary.
Hey, and I'm Victor. It is my 4th year on this staff. I'm a junior in computer science because computer science is the best department. And this is the best class in the best department, so it all works out. I can see some of you staring at me and glaring right now, so that's it. Thank you.
So, Victor, I thought you were going to follow up Ian's with, this class is scary, and I'll help you realize that it's true. Just kidding.
This class can be scary.
Okay. All right. Thank you all very much. You will get to know all of these people more as the semester goes on. And every time you see any of us, you should feel free to introduce yourselves. And when I say any time, I mean every time, because we want to know you, and it just might take us a while. So don't be shy, I guess, is the upshot there. So you guys demand that they tell you who they are.
Just not when I have my headphones.
Oh.
If you're not poke and be like, oh yeah, my name is this.
No, they can poke. That's fine.
That's going to cost extra.
Yeah, okay. All right. Okay, so thank you very much for coming. Yes?
I think you brought up office hours.
We're going to talk about it. Okay, so now we're at this awkward stage in a dinner party because you know a lot about us and we don't know anything about you at all. And you may not know much about each other. So I want to ask you a few questions, both so that I can get a feel for the community of the class, but also so you can see what's going on here and kind of know what your class is like. So raise your hand if you are a CS major right now. Any of the CS majors, raise them high. This is a histogram over the class, right? You're basically showing us a frequency diagram by raising your hand. Some people use clickers. I use bodies. Okay, raise your hand if you're an ECE major. Oh. Raise your hand if you are neither of those. Okay, so look at the diversity there. This is a CS course, and yet, among those 3 options, that was the smallest population. So keep your hand up if it was something else, and you are willing to chat with me for a second. So keep your hand up if you're willing to chat with me for a second. Okay, yeah, it was you. So what is your major? What is your major?
My major is math.
Okay, math and CS or straight math?
Just math.
Straight math. Okay, cool. So I think that among the people with other majors, there's a great variety from all over campus. Math is in LAS. Raise your hand if you're also a math major, strict math major. Okay, so you guys should all know each other, right? Look for each other, and because you have these similar experiences, it might be nice to know. Now, I have another question for you. You're not quite off the hook yet, okay? So you spoke out loud in this classroom, right?
Yeah.
Did it hurt?
Hurt?
Was it painful?
Painful? No, not at all. It's just good.
She said, no, not at all. It's just good. Okay, so I want all of you, I mean, I can't force you to do this, but to create a New Year's resolution that says at some point during this semester, I am going to speak in this classroom. Okay, and I'll try to give you lots of opportunities to do that. Just because it's more fun. It is more fun for you to listen to each other than it is for you to listen to me. I'm quite certain. Yes, yeah, I think that's true. Okay, so I would like it very much. So your participation is welcome. Your participation is welcome, and you are always welcome to ask a question if something is not clear to you. Guarantee you, if something isn't clear, it's probably on me, not on you. It was probably harder for you to get into this place than it was for me. So yeah, it's probably on me. Feel free to ask. Feel free to interrupt. This I'm always looking for. All right, so introductions are done. We can now start the dance music. No, we can't. I'm not going to spend a lot of time going over the website because you're here. The fact that you're here means I know you know how to read. So I'm going to leave you and in the presence of the website and let you browse it on your own for course policies. But don't do it quite yet. because I have not updated all of the new policies for this semester. It'll happen within the next 24 hours or so. Of course, I said that 24 hours ago, but this time really. In particular, we're changing up how exams are administered, and we'll be very clear about that. And the result of that is to change the grading process a little bit, the grading distribution a little bit. So within the next 24 hours or so, all of this information will be updated. One item that is important to you is that our course communications almost all happen via Piazza. So right now, you can go up and sign up for the CS225 course Piazza. I think it demands you use your @illinois.edu email. If you do not want to use that email address, if you prefer to remain anonymous, let us know and we'll help you get onto the course Piazza. I don't think it's open to everybody. So let us know if you'd like to be anonymized. That's fine with us. Otherwise, posting to the Piazza for this class is anonymous to each other, but not anonymous to us. We're a little power hungry in that way. That's a joke. Okay, not a funny one, but all right. Also on this list is this notion of academic integrity. So here's the thing. In this class, most of the issues with academic integrity center around the solutions to the machine problems. And I don't know if you know it. I'm not sure if you've heard, but I found out the solutions to all of our MPs are on GitHub. Did you guys know that? No, I know. I've known a while. So here's the thing. We know they're out there. They've been out there for a long time. We don't change them because they're so good. But here's the way I would like you, I can't say you should, but here's the way I would like you to view the exercises that we give you to do in the class. You should view them as opportunities for learning and growing your brain in such a way that you can conquer these challenging problems is our goal for you. We've crafted them carefully so that they're just the right difficulty, so that they cause you to stumble in just the right places, so that by conquering those issues, probably with our help or possibly with our help, you learn stuff deeply. This is a top place, right? Like, you are the elite, whether you really think of yourselves that way or not. And the ability to push through a hard problem on your own, relying on your own creativity, that's your stock in trade. That's what's most special about you, not your ACT score, but your ability to press through and creatively solve a problem. So that's what we want to engender here. That's the kind of attitude toward the course material that we want to engender here. All right, so there's my little preachy stuff. I want to follow it up with, we have, seriously, a ton of resources. Pretty much any time, night and day, you can get help with an issue that you are having with course material. We're always on Piazza. We have open lab hours all day, every day. We don't leave you in the dust. So please, please reach out to us before you reach out to GitHub for pressing through your problems. We give better hugs than GitHub does. All right, any questions about that? The policy and disincentives are spelled out, will be spelled out more carefully on the website, but that was just my riff on academic integrity. Any questions about it? Okay, all right, I didn't even need to do that, right? Okay, so every lecture, every class meeting, I should say, starts with announcements. So I actually feel like we're just starting right now. This is our first moment where I'm telling you what's sort of on the horizon and what you need to know over the next few days. So the announcements are, we will be doing a homework 0. It's intended to show you what we expect you to know from your discrete math experience. MP1 is also going to be available soon. Both of those are due next Friday. The instructions for turning them in will be on the assignments themselves. So the fact that we're not telling you details right here, no big deal. We'll make sure that that's clear as soon as they are, or when they are released. The other important piece of this is that we have lab exercises for you to do this week during sections. And those will meet, and they're quite important because they model the way lab sections will go for the rest of the semester. So you should go. It's a good idea. Also, in conjunction with those sections, every section will contain a short 15 to 20-minute quiz that together will be like a midterm in this class. So it's quite important that you participate in these sections. Now, of course, we will have policies that allow you some flexibility with dropping some and such, but suffice to say, we're putting a little more importance on your mindful participation in sections than we have in the past. Okay, and then finally, Wade and I decided that we would like to hold Debug Your Brain sessions in this building before this class and after the other class every Wednesday and Friday. So every Wednesday and Friday, you can find either one or both of us in that room, which is upstairs somewhere. I actually haven't even been there. So, and we're happy to talk to you about anything. We'll probably be more interested in whiteboard discussions than we are just plain old MP debugging, but we do that too. So whatever you like to talk about with us, you're welcome to come here. If those times don't work, you can send us email and set up an appointment. We're happy with that. Or post to the piazza that you'd like an appointment. Yes?
Do we have to get 12 or
No, it's open. That door is open during that time. So it's drop-in. It's usually, there are usually, I don't know, my history, about 5 to 10 people there persistently. So, yes? This is our office hours. Yes. Yes, these are our office hours. These are our reliable weekly. We promise to be there. One or both of us promise to be there at those times. And it doesn't matter which of us you talk to, because we're kind of on the same page. Yeah? No, you can send us. So first of all, course staff, there are tons of office hours all day, every day. For Wade and I, you're welcome to try to make an appointment, and we'll put you on our calendar. But that should be done via the piazza or email. Okay, there's no standing office hour kind of thing. Okay? All right, any other questions about this stuff, the announcements? Okay, that means it's time to start working on course material. So what's this course about? The wave behind is a metaphor for what this course is about. What do you think the wave represents in the metaphor? What do you think the wave represents? Yeah? Flow of information. Oh, that's even better. I would have truncated it at information or data, right? But he added the connection to the water. It's artistic even. Thank you for that. So yes, so that giant wave is intended to represent information or data. Now, here's us. Here's us, okay? Here we are. We're trying to ride that data. We want information from it. We want to master it. We want to improve the world with it. Well, wait, the metaphor dies pretty quickly, right? The point here is that I have actually drawn this picture incorrectly. The truth of the matter is that there is so much data that surfer really looks about like this. Even that looks too big, right? Really, it's like this. And in fact, no, that's there, it's that. And moreover, there are sharks in the water. There is so much data that we actually have very little hope of taming all of it. So we better have very, very clever ways of dealing with that. We better have ever increasingly clever ways of dealing with the onslaught of data that we face. Now, what was I going to say? Oh, this is the first class where we intend to teach you some of the, or help you learn some of the fundamental questions that you should ask and the issues at play that come up when you're dealing with data in general. They will take the data and they'll meld it with the characteristics of the machine and get you asking all the right questions and give you a fundamental set of tools that you can use to address and to begin to create the answers to those questions. Now, I will also tell you that the syllabus for this class has not changed in probably close to 30 years. Not much. I mean, twiddles, right? Tweaks here and there. But not much. And the reason I point that out is that this is foundational. How long has it been since the calculus book changed? Come on, right? So what we're studying here is considered basic knowledge. You cannot claim to be a data scientist. You cannot claim to be somebody who brings to bear a classic education in computer science without dealing with the issues that we're going to talk about in this class. Okay? Any questions about that or comments? Does it scare you? Is it like, oh, shoot, 30 years, bummer. No, it shouldn't be. It's okay. It really is okay. You'll be okay. So, for example, here's another metaphor. Here's the deal. Raise your hand if you've been in that building. Raise your hand high. Okay, raise your hand if you have not been in that building. Okay, so for those of you who have not been in that building, it's really fun. So that's Memorial Stadium. It's super fun to go there and to experience a football game. And so I sort of challenge you, this is in this side, I sort of challenge you to make that part of your undergraduate experience here. It really is like a carnival in there. And in particular, I like the marching band. Is there anybody in this room from the marching band? Shout out to the marching band. I don't know how you guys do both. I don't know how you study CS and do that. It's astounding. Okay, so that said, Memorial Stadium holds how many people? A lot. I'm going to say 10,000, higher or lower? Higher. I'm going to say 100,000, higher or lower? 55,000? Higher. 80,000. A little lower. It's probably, I think, between 60 and 70,000. Anybody want to correct me? Anybody know the actual number? I think if we were in a Psych 101 class, somebody would know the exact number. 65,000, you think? 65,000 people. Okay, let's say 60,000 people. Right there, all at the same time. Oh, sadly, though, I think it's usually about 10,000 people are actually there. Oh, no, okay, so 65,000 people in that situation, that setting, and I want to find Siri. So Shahida was a TA of ours that wasn't reassigned to our class last semester, and this is my way of protest. So we're still looking for Siri. We call her Siri. CS374 swiped her from us. So suppose that Siri is somewhere in that stadium. How are we going to find her? Anybody have any suggestions? She's in that stadium. I know she's in that stadium because I called her friend, said, where's Siri? She's in the stadium. How are we going to find her? Yeah?
2 ways.
No, you only get one.
Oh, I only get one?
Yeah, choose your best.
Okay, very well. We'll divide up.
Okay. They already did that for you. It's, yeah, the stadium is already divided into sections. Yep.
So, for each of them,
I don't care. What's the idea? Search through the sections. Okay, like this. Like this. So you expect one person in each section going, hey, are you Siri? No. Are you Siri? Are you Siri? Is that what you're suggesting? Okay, that's good. Let's talk about that way for just a second. Okay, so he suggests dividing up the stadium into sections, right? And having some agent or some processor or some friend of Siri, however you decide to classify it, looking through each section person by person. Now, for the sake of argument, let's pretend like there's one section in the stadium. Okay, for the sake of argument, let's pretend like there's one section in the stadium. And I'm going to do that. Do you like that idea? Are you Siri? 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 Do you guys want to wait for this anymore? Just shake your head. Are you Siri? Wouldn't it be fun if your name was Siri? Actually. All right, so how long are you guys going to wait for me to do that? You're already bored, right? I know you. All right, so let's talk about this particular algorithm for just a second. I'll revisit the sections idea in a sec, but let's talk about this particular algorithm. Let's let variable n represent the number of people in the stadium. How much time does it take to process the entire stadium to find Siri? How much time will it take? Order and time. This is the first moment where CS173 drops its little sparkles on us, okay? What we're saying here is that the time it takes to find Siri is proportional, that means a constant factor of the number of people in the stadium. Is this good news or bad news? That's bad news, right? Surely we can be more clever than that in finding Siri, okay? Because 70,000 people is a lot, and at Michigan it would be even more. So let's not do that thing. All right, so we say, in fact, that since a constant factor times the number times n is a linear function of n, we say the time it takes to find Siri in that stadium is linear. Can we do better? Are there any ideas for doing better? Yeah? What did you say?
The way you had us guess the number of people.
Guess the, oh, binary search. Basically, when I had you assess how many people were in the stadium, I was doing binary search, right? For kind of what you felt like was the number of people in the stadium. How would we use that to find Siri? How would we use it to find Siri? Sorted somehow, good. Okay, so if we had people sorted by last name, then we could use that strategy, right? Well, we don't, darn it. And it would take a really long time to say, yo, everybody, get up and get yourselves in order. Ah! That, I'm not sure we want to wait for that. In fact, they're probably still doing it right now. Don't know. Yeah? You have to yell. Oh. This is awesome. This is actually my favorite one. This is actually my favorite suggestion for a couple reasons. Okay, so let me get this started. So what's going to happen is I'm going to ask one person if they're Siri, and then they're going to ask the people around them, and then each of those people asks the people around them. What does this look like as you imagine this happening in your brain? What does this look like? It looks like the wave. It looks like the wave, right? The questioning is perpetuating out and ever growing as it goes across the stadium. Raise your hand if you don't know what the wave is. It's okay not to know. It just really means you should go to a football game. Okay, I want to do the wave in this room. Is that okay? Okay, so Wade, you're going to start it. So here's your algorithm. Right, put your hands in the air when the person to your left or in front of you does. Okay, so when your neighbor puts their hands in the air, you follow pretty much immediately. And then I guess I should sit about right here, right? And I'll start. Did it make it? Kinda. I was like feeble. I hate to tell you this, but if I put that wave compared to the last hour's wave, they have you guys all beat. Do you want to try again? No, it's not worth it. Okay, So the question is this a linear time algorithm? Is this a linear, will it take us proportional to the number of people in the room if we do that more, if we do that carefully, like, okay, you tell all the people around you, you tell all the people around you. If we really grow it authentically, will that take time proportional to the number of people in the stadium? No. In fact, that edge of the wave is growing close to exponentially, given the constraints of the building, which means that the number of steps it's going to take is actually logarithmic for some base. We don't know what that base is really quite. Now, later on, we'll see pictures of functions, and you should remember from CS 173 that when things grow logarithmically, they're growing very slowly. So this algorithm actually can do a lot of work in a very short time. The time it takes is growing slowly as the number of people in the stadium grow. So I like this for two reasons. I like the idea of tell your neighbors and they tell their neighbors, etc. I like that for two reasons. One, because it's the wave, and two, because it's really a good algorithm. There's one more algorithm that nobody has suggested. I mean, there's a lot more, but there's one that's just like, it's like begging to be suggested, yeah? Yeah. Hey Siri, are you in the house? Look at what that assumes. So that's exactly what you and me, like this, brownie points for you, which means I owe you a brownie, okay? So think about what that means. First of all, think about what it's doing. It's asking something of the people in the stadium, I mean your data, I mean the people, it's asking something of your data or the people all at the same time. Now, that is a computationally interesting question. How do you facilitate access to all the data all at the same time? How do you broadcast essentially code, essentially algorithms? And that's an interesting question. And one that we may come up later in the course. I'm not sure. Okay, ready to connect. That's not what I want to see. Let's try. Okay, any questions about this? Do you have any other ideas for sorting? Or for finding Siri in this thing that you'd like to talk about? Feel like are missing? Hold on. Okay, thanks. All right. All right, so here's another metaphor. I want to know if your closet looks more like that one or like that one, okay? All right, so raise your hand if your closet looks more like this one. And my hand is raised here. I'm being honest with you. So raise your hand if your closet looks more like that one. Okay, and raise your hand if your closet looks more like that one. Okay. All right, okay. We can infer a lot from that, right? My husband was in the crowd last lecture. He was sitting in the back because he's teaching this semester too. He was sitting in the back, and I didn't know it. I'm like, I wonder if I should lie or tell the truth here. But it's his mess in the closet, not mine. Now that's a lie. Okay, so all right, so let me ask you this. I bring you, so now we've classified each other, right, into these types. Now I bring you a whole big pile of clothes. I want to know, I bring you this whole big pile of clothes. Is it easier to construct this kind of closet or to construct this kind of closet from that whole huge pile of clothes? In no particular order. Which one? Okay, which one is easier? Is it easier to build this one or is it easier to build that one? Point to the one you think. Okay, I think this one's probably easier because you just shove it in there, right? All right, so this one's easier to build. Here's the question. You want to find your purple shirt. Which closet is easier to use? Don't point to that one. Don't even point to that one. Okay, all right, so fine. If this is a hash table, like if you just know where your purple shirt is, then okay, you win, fine, whatever. But in general, organizing your data and storing it in memory in a predictable way, in an organized fashion, oh my gosh, That's like 9/10 of the course. Well, no, it's about half the course. Half the course is algorithms, like finding something in a stadium. The other half is how can you be clever about storing your data in such a way that it is useful to you, that it's easy to use in exactly the way that you want to use it. All right, so I want to say one thing about this, because I think that this is true. And that is, if you have a purple shirt and you can't find it, but you need it, but you can't find it, what do? Exactly, you buy a new purple shirt. And then you put it in there and it gets lost again, right? And then you need another purple shirt. What do? Mom, can I use your Amazon Prime? You buy another purple shirt. I'm not advocating for this at all, by the way. Pretty soon you've kind of lost track because you've got too much data. You have a lot of redundancy in your data that is not serving any good purpose. Though, of course, reliability-wise, you're always going to have a purple shirt. It's just a question of whether you can find it or not. Anyway, this metaphor can go for a while. Maybe we should stop here. All right, any other comments or questions about closets and organizing shirts? Okay, yeah? Right. So if you buy purple shirts all the time and then suddenly you need a black one, the game's over. Okay. All right. Metaphors abounding here. We're not going to do metaphors all semester. Instead, we're going to do a lot of programming. And hopefully, we'll also do a lot of thinking. We'll be pretty careful not just about getting code to do interesting things, but thinking circumspectly about how we write the code and why we choose to write the code that we do, and doing it clearly and understanding the value of the code itself, not just its running time. So you shouldn't listen to me when I talk about what this course is like, because I think probably your friends, you already know what this course is like, right? Like, this course has been around a long time. Your friends will have told you the value of this course and the way that it makes you become a better programmer and the way that it prepares you for your future courses. And then there's that crass one about the way it helps you get an internship. 374, actually, I think is just as good at that. Okay, but as I alluded to before, this course is foundational. You just really need it. Okay, let's see. So let's talk a little bit more about you. So raise your hand if CS 125 was the way you satisfied the prerequisite material for this course. Okay, 125. And raise your hand if ECE 220 was the way you fulfilled the prerequisite programming course for this course. Raise your hand. So that's a little bit more toward 125. Raise your hand if it was something else, some other course. What was your course? Oh, C++. Oh, man, you're going to be bored the first 4 weeks, which just means you'll be on top of it. It's good. It's all good. All right, any other courses? Yeah? CS 101. Okay. We should talk. You'll probably be fine. You'll probably be fine. You'll probably be fine, but we should talk just in case, just to make sure that the elements of these courses aren't skipped, okay? I don't mean that to be scary. Awkward. Sorry. I was going to give a brownie to that guy. I now owe it to you, actually. So where's the brownie? Why don't you just give both of them brownies? I'll give them both brownies. Okay, so we should talk. If 101 is the course that you're using to satisfy the prerequisite for this class, there are some things I'm going to want to ask you. It's not a deal breaker, but I'm going to want to ask you some questions. Okay, so let's talk about these prerequisites for a second. Java is an object-oriented programming language, which means that the people who have taken that class are very comfortable in object land. Okay, you understand what classes are. You are pretty facile with developing them. You can think in terms of objects. On the other hand, people who have come from a C class, which may include 101, but that's one of the questions I'm going to ask, well, they have a different construct that, let's see, it's the construct that gives them access and thereby control over memory. What is it? Pointers, very good. So people who are coming from ECE 220, I expect to be darn good at pointers, okay, at dealing with pointers, which is why we choose C++ for this class, because it's an object-oriented programming language that's based on C, and so it gives you the ability to manipulate memory very directly via pointers. Now there are other, all right, so it's perfect. Now here's, though, the problem. I don't know whether to look at it as everybody's missing half, so I don't have to do anything, we're all the same, or everybody's missing half, so I better do all of this in this room. And because we don't want to leave anybody in the dust, we're actually going to spend the first 4 weeks of the semester talking pretty carefully about C++'s characteristics as an object-oriented programming language and as a memory authentic language, a language in which we can manipulate memory. So we'll spend a lot of time bringing you up to speed on what's important about C++, okay? And I think you will find tidbits, all of you will find tidbits, even if you've actually had a C++ course before. Looking at it from a slightly different angle will be good for you. Okay, any questions about this? The other prerequisite for the course is the discrete math course, 173 or Math 213, CS 173 or Math 213, and homework 0 will show you, is designed to show you what we expect you to know from the discrete math course. Now, I understand that it's very common to be concurrently enrolled in 173 and this course. And in my experience, that works fine because the first 4 weeks, while we're doing this, the CS 173 instructors are blasting through Big O and induction, and you'll be fine because those are the things that we need most. So, so I think it works okay to do 173 concurrently, though I'm feeling a little strange having said that on the microphone because I'm not sure the curriculum people want me saying that very loudly. So, all right, any questions about it? Okay, well, we should get started. So I have some slides that I could trace, but I think I'll spend a few minutes instead actually showing you concretely how to write very, very, very simple code in C++, because I think it will make things less abstract for you. So we'll see how that goes. I want to do that. I want to do that. Who's yawning? There's no yawning here. Yeah, okay. All right, back row people, can you see that? Back row people. Yeah, okay. All right. I want the chair. Okay, so I am logged into my Surface Pro 3. I'm going to tell you this as if, you know, I'm not expecting you to have set up exactly the same system I have. So I'm going to talk a little bit about my system, and you should feel free to ask questions. So I am running, I don't know, I think this is Git Bash on my Surface Pro 3. Bash now comes native with Windows 10, so you probably don't have to jump through the hoops that I had to jump through when I first installed this system. And of course, I'm in a rut, right? Like I'm not making any changes. So I am where I am, and you can be in a better place with just a little bit of Googling. Now, what I am going to do, though, and what I suggest you do as well, is I'm not going to do my computation on my own machine. I'm going to exploit remote access to the lab machines by saying SSH, secure shell of me, into rem Linux. And that's just a remote box, and I'm going to do it as sort of simply as possible. I'm not using anything special about it. And so now I have a command prompt. Okay, so here was something I forgot to ask at the beginning of the hour. So I'm asking about text editor. Text editors. Raise your hand if you use Vim already. Raise your hand if you use Emacs already. Okay, if you raise them high. This is, like I said, this is a histogram. It's important for us to be able to see arms. Okay. Raise your hand Sublime Text. That's where I'm going. I'm not there yet. I haven't had time to like actually do development, but that's probably where I'm going. Raise your hand if
Adam.
Adam.
Oh.
Okay, not yet, Wade. It'll happen. That's the GitHub suggested version, right? Like, okay, raise your hand if something else. Hey, what are you using? What is it? Gedit. Okay, yeah, good. VS Code. Oh, I don't know that. Oh, Virtual Studio. Ah, okay. Well, yeah. Yeah, right. Yeah. All right. So here's actually the upshot. Here's the upshot. Choosing your text editor is a personal journey. Okay, just like religion. Not even kidding. And so all of us are happy to show you the way, the one true way. But really, you find your own one true way. Tutorials are abound for all the different systems or all the different tools, and they really are just tools. So you have to find the one that works best for you. I happen to use Vim because I've used it for, yeah, I'm not even going to do that. So I'm going to edit a text file here. I'm going to edit a text file that's going to be our first C++ program. Okay? There it is. There's nothing in it. Now, when you speak a C-based language, the only thing that ever happens upon execution of that language is the function called main is executed. Okay? Now, what does main look like? Well, it has a return type. It has a name. It has a parameter list that I'm not going to use here. I better return something, and that's it. So I have written our first C++ program. All right? Now, I can compile that program, but I don't want to do so yet because it's too boring even for me. So what I'm going to do is use this opportunity to show you the process of declaring variables so that we can talk about them for just a minute. Based on this example, you already know that integer is a type, and so rather than talking about something else, how about if I declare an integer, something whose type is integer? Give me a variable name. Somebody raise their hand and give me a variable. Age? Okay, fine. Int age. Okay, fine. Another type is double. It's kind of the closest thing we're going to ever see that we're going to worry about to floating point. If you really care about precision, you'll be doing slightly different things. But this is really a simple way for us to talk about types. Now, to have a floating point. But here's the thing. If you care exactly what types are available to you in C++, you can Google it. Primitive type C++, and you can get the whole list. So I'm actually not going to spend a lot of time doing it here. So instead, what I'm going to do is give you a few of them and talk about them for a second. Okay, so here's some examples of primitive type variables. And I want to talk about what they all have in common. And this is going to be true of any variable that we name. They all have a type. So Python be damned. They all have a type. They all have a name. They all, whether you know it or not, have some location in memory. And they all have a value. They all have a value. Okay, those four things. So let me write those right there. All variables have name, type, location, value. Where is age stored? all in your head, is what they tell me. Age is just a number. Where is age stored? Yeah? Somewhere on the stack. And the salient point there is we don't know exactly. But it is stored somewhere, so it has a location. What is its value? It has a value. What is it? It's garbage. We don't know what it is. If the compiler is kind to you, it might give it a 0, but you can't necessarily depend on that. It's not specified. When you declare a variable, its value is garbage. Now, when I say garbage, it means I can't test against it. I can't say, if the variable is garbage, bark 3 times. I can't do that. I have to have a testable value. All right, so I want to show you that this code compiles as is, just to basically take you through what will be our compilation process. We're using the compiler Clang. If I have done nothing wrong, Clang will essentially look at the code that I have written, check it for type and syntax, so type coherence and syntax, and then it will create machine. If those things are okay, it will create machine code reflecting my program. Okay, everything was okay. So now there exists, look at that. Okay, I was in the wrong directory, but it doesn't matter. There exists an executable called a.out that I can now run. It's the machine code corresponding to my program. What happens when I do that? When I execute this code? Nothing. I didn't ask it to do anything that I could see. I only asked it to declare those variables. And right here is where this is not very interesting. Next time will be very, very interesting. So this is a good place to stop.